The Pacific Ocean is not merely a body of water. It is a vast, suffocating void that swallows fleets and empires alike. In the early days of the war, Imperial Japanese planners looked at a map of the globe and saw this void not as a threat, but as their greatest ally. They calculated that for the United States Navy to fight in the Western Pacific, it would need to stretch a logistical tether over 4,000 miles long. Japanese admirals, steeped in the doctrine of the decisive battle, believed this distance would render the American giant sluggish, predictable, and ultimately vulnerable. They were convinced that a modern fleet could not operate indefinitely far from a major shipyard. In this war, battles were won not just by bullets, but by logistics, and the Empire was certain the Americans would lose the war of supply. At the Untold War Tales, we believe the best way to honor the past is to never let it be forgotten. If you believe in that mission, hit the subscribe button and join us on this journey. Now, let us return to the waters of the Pacific, where a grand miscalculation was taking root. For the Imperial Japanese Navy, the strategy for the coming conflict was built upon the interception operations doctrine. Their entire naval philosophy relied on the premise that the United States Pacific Fleet would have to steam across the ocean to relieve the Philippines or strike at the Japanese defensive perimeter. Japanese strategists envisioned a war of attrition as the Americans crossed the expanse. Submarines and aircraft would whittle down the U.S. fleet as it labored westward, exhausting its fuel and its crews. By the time the Americans reached the area designated for the decisive battle, likely near the Marianas or the Philippines, they would be battered, low on supplies, and far from help. The Japanese fleet, fresh and operating close to its bases, would then emerge to deliver the killing blow. This confidence stemmed from a deep understanding of naval mechanics. A battleship was a beast of insatiable hunger. A vessel like a North Carolina-class battleship burned hundreds of tons of fuel oil every day while underway. Destroyers, the sprinting greyhounds of the fleet, had even shorter legs, requiring refueling every few days to remain combat effective. In the Atlantic, the British Royal Navy and the U.S. Navy could rely on friendly ports and shorter distances, but the Pacific was a different world. From Pearl Harbor to the Solomon Islands was a journey of nearly 3,000 miles. From the west coast of the United States to the heart of the Japanese Empire was double that. Japanese Admiral Isoroku Yamamoto and his staff mocked the idea that the Americans could sustain high-tempo operations over such distances. They viewed the American Navy as slow, not because of the top speed of its ships, but because of its operational constraints. They believed the Americans would be forced to fight in a predictable rhythm, sortie from Pearl Harbor, fight a brief engagement, and then retreat thousands of miles back to Hawaii or the West Coast to rearm, refuel, and repair. This operational pause would give Japan time to recover, fortify, and prepare for the next round. It was a rhythm of warfare that favored the defender. The Japanese High Command called it the short war strategy, gambling that the Americans lacked the stamina and the logistical wizardry to turn the ocean into a highway rather than a barrier. In the opening months of 1942, it appeared the Japanese assessment was entirely correct. As the U.S. Navy scrambled to stem the tide of Japanese expansion, the logistical strain was immediate and crippling. American commanders found themselves shackled by the tyranny of distance. Ships arrived in the South Pacific running on fumes. There were no major repair yards south of Pearl Harbor. A damaged propeller or a burnt-out engine meant a vessel had to be withdrawn from the war for months, steaming slowly back to a dry dock in Sydney or Pearl Harbor, leaving the front lines dangerously thin. The struggle for Guadalcanal exposed this weakness to the world. The U.S. Marines ashore were barely hanging on, and the Navy supporting them was stretched to the breaking point. Admiral Nimitz and Admiral King watched with growing frustration as their warships spent more time transit to and from rear bases than they did patrolling the combat zone. The Tokyo Express, fast Japanese destroyer runs, delivered troops and supplies at night and vanished before dawn, operating on short interior lines. The Americans, conversely, were at the end of a tenuous supply chain that zigzagged across the ocean to avoid submarines. Fuel tankers were scarce, and the transfer of oil at sea was a rudimentary, dangerous affair, largely avoided in rough weather or combat zones. Japanese observers noted these struggles with grim satisfaction. The Americans seemed bound by the traditional rules of naval warfare, rules that dictated a fleet could only extend its arms so far before it had to pull back. The Japanese counted on the elastic defense. They would absorb a blow, wait for the Americans to retreat for supplies, and then snap back to reclaim lost ground. They scoffed at the soft American sailors who expected ice cream and fresh meat, believing that such luxuries required a logistical footprint so heavy it would anchor the U.S. fleet in place. However, a different kind of war was being plotted in the grim offices of the U.S. Navy's logistics planners. Men like Admiral William P. Calhoun and Admiral Richmond K. Turner looked at the same vast distances that gave the Japanese confidence and saw an engineering challenge rather than an impossible wall. They realized that if the U.S. Navy played by the established rules, the war might drag on for 10 years. The Japanese assumption that a fleet needed a land-based harbor was the cornerstone of their entire defensive strategy. If the Americans could kick that cornerstone out, if they could make the fleet independent of the land, the entire geometry of the war would collapse. The Japanese mocked the slow U.S. Navy because they measured speed in knots and operational range. They did not anticipate that the Americans were about to redefine the very concept of naval mobility. The mockery was based on the static past. The American response would be built on a fluid, industrial future. The ocean was about to change from a defensive moat into a conveyor belt of destruction. But first, the engineers and planners had to invent a way to bring the shipyard, the fuel depot, and the ammunition dump directly into the combat zone. The tyranny of distance was about to meet the ferocity of American industrial imagination. The realization hit the American high command like a splash of cold salt water. To win the Pacific, the Navy had to stop acting like a visitor and start acting like a permanent resident. The traditional model of sortie and return was a recipe for a stalemate. If the fleet had to return to Pearl Harbor every time a ship needed fuel, ammunition, or repairs, the Japanese would always have the initiative. The solution proposed by the logistics planners was as radical as it was ambitious. They would not just build more ships, they would build a mobile infrastructure that could follow the combat fleet anywhere. They called it the service squadron, but the concept was far grander. It was the birth of the floating base. This idea required a fundamental shift in naval architecture and strategy. Until this moment, a base was synonymous with land. It meant concrete piers, deep-water harbors dredged from coral or mud, heavy cranes bolted to bedrock, and massive fuel tanks buried in the earth. The U.S. Navy decided to unmoor these essentials. If the fleet needed a fuel depot, they would build a tanker that could hold millions of gallons. If they needed a warehouse, they would construct a cargo ship designed not just to transport goods, but to dispense them at sea. If they needed a hospital, they would put operating theaters on a hull. The goal was to create a logistical shadow that mirrored every move of the combat fleet, a train of support vessels that rendered the tyranny of distance obsolete. The scope of this undertaking was staggering. Planners in Washington and Pearl Harbor began sketching out requirements for a fleet that had no guns to fire in anger, yet was just as vital as the carriers and battleships. They needed ships that could distill fresh water from the ocean by the thousands of gallons. They needed floating refrigerated warehouses to store the beef and vegetables that kept morale high. They needed ammunition ships, floating bombs, essentially, that could handle delicate transfers of high explosives in the rolling swells of the open ocean. One of the most critical components of this new strategy was the development of the fleet train. This was not merely a convoy of supply ships. It was a highly organized, mobile support system. Admiral Nimitz gave his logistics commanders a blank check and a heavy burden. The mandate was clear. The combat ships must never have to leave the front line for lack of supplies. The supplies must come to them. This meant the logistical tail had to be fast enough to keep up with the teeth. Old, slow freighters would not suffice. The Navy needed new, fast oilers and cargo ships capable of matching the cruising speed of a carrier task force. The engineering challenges were immense. Transferring fuel from one ship to another while stationary in a harbor was routine. Doing it while both ships were steaming at 12 knots in the open ocean was a terrifying exercise in physics and seamanship. Hoses snapped, lines parted, and collisions were a constant threat, but the engineers and seamen practiced relentlessly. They developed the span wire rig, a system of tensioned cables and winches that allowed hoses to be suspended between ships, compensating for the heaving motion of the waves. It was a mechanical ballet performed by heavy machinery, and it was the key to unlocking the fleet's mobility. Simultaneously, the Navy began to procure vessels that defied traditional categorization. They needed repair ships that were essentially floating factories equipped with lathes, welding rigs, and foundries. These ships, designated ARs, repair ships, and ADs, destroyer tenders, were staffed by men who were often older, experienced machinists, and tradesmen recruited directly from civilian industry. They brought with them the know-how to fix anything from a cracked boiler casing to a sophisticated radar set. These men were not career sailors. They were mechanics in dungarees who happened to be at sea, and their ingenuity became legendary. The floating base concept also extended to the morale of the sailors. The planners understood that men could not fight indefinitely without rest and recreation. So, the floating base would include hotel barges, ice cream barges, and ships dedicated to mail delivery. The logistical planners were effectively building a mobile city that provided everything a sailor could find in San Diego or Norfolk, except for shore leave on solid ground. This psychological component was just as vital as the fuel oil. It meant that a sailor on a destroyer could spend months at sea, yet still receive letters from home, eat a warm meal, and sleep in a dry bunk, knowing that the support system was right behind him. While the Japanese were fortifying their island bastions, pouring concrete into bunkers and digging caves, the Americans were pouring steel into this mobile infrastructure. The Japanese strategy was static, rooted in the geography of the islands they occupied. The American strategy was dynamic, rooted in the industrial capacity to project power. The floating base meant that the U.S. Navy was no longer tethered to a specific map coordinate. They could strike the Marshalls, and then, without returning to base, pivot and strike the Marianas. This strategic pivot went largely unnoticed by Japanese intelligence at first. They saw more supply ships, certainly, but they interpreted them through the lens of traditional warfare, convoys bringing supplies to a forward base on land. They did not grasp that the base was the convoy itself. They did not understand that the Americans were erasing the operational pause. As the shipyards in the United States churned out hull after hull, the pieces of this massive puzzle began to assemble in the endless waters of the Pacific, ready to support the greatest naval offensive in history. The floating base was no longer a theory. It was becoming a steel reality, and it was heading west. While the fast carriers and battleships captured the headlines and the newsreels, a strange and ungainly fleet was quietly gathering in the backwaters of the Pacific. This was the Concrete Armada, a collection of vessels so utilitarian, so utterly devoid of glamour that they seemed to belong to a construction site rather than a naval war. Yet, without these ugly ducklings, the gleaming swans of the battle fleet would have been helpless. The U.S. Navy, facing a critical shortage of steel, turned to an ancient material to solve a modern problem: reinforced concrete. The logic was purely pragmatic. Steel was precious. It was needed for carrier decks, submarine hulls, and tank armor. Concrete, on the other hand, was cheap and abundant. So, the engineers designed barges and lighters made of stone and cement. These were not ships in the traditional sense. Most had no engines and had to be towed thousands of miles across the ocean. They were massive gray slabs that wallowed in the swells, earning them affectionate, if derisive, nicknames from the sailors who manned them. But their value was incalculable. Among the most important of these concrete oddities was the BRL, the barge refrigerated large. In the sweltering heat of the tropics, where food rotted in hours and fresh meat was a distant memory, the BRL was a floating oasis. Inside its thick concrete hull, massive compressors kept tons of beef, butter, eggs, and vegetables frozen solid. A single BRL could feed a task force for weeks. When one of these barges arrived at a forward anchorage, it was greeted with more enthusiasm than a visiting admiral. It meant steak dinners and fresh salads, small luxuries that kept the fighting spirit alive in men who had not seen civilization for months. But the concrete fleet was not just about food. It included floating warehouses for dry goods, barges packed with spare parts, and even floating hotels. These vessels effectively extended the American coastline into the middle of the ocean. They acted as mobile depots that could be towed to a captured lagoon, anchored, and immediately begin servicing the fleet. There was no need to wait months for engineers to build warehouses on an island. The warehouse simply arrived, dropped anchor, and opened for business. Perhaps the most impressive feat of engineering in this support fleet, though not made of concrete, was the floating dry dock. These were the true game changers. A dry dock is typically a massive, permanent structure excavated into the land, used to lift a ship out of the water for hull repairs. The idea of a floating dry dock was not new, but the scale at which the U.S. Navy deployed them was revolutionary. The ABSDs, Advanced Base Sectional Docks, were behemoths. Built in sections in the U.S., they were towed separately across the Pacific and then welded together in calm lagoons to form a single massive cradle capable of lifting a battleship or an aircraft carrier completely out of the water. Imagine the complexity of this operation. A battleship like the USS South Dakota weighs nearly 40,000 tons. To lift it requires a structure of immense strength and buoyancy. The ABSDs were essentially man-made islands with walls that could be flooded to sink the dock, allowing the ship to float in and then pumped out to raise the ship dry. These docks allowed the Navy to perform major structural repairs, fixing torpedo damage, replacing propellers, scraping barnacles, right on the front lines. A job that used to require a 6-month round trip to Pearl Harbor or Bremerton could now be done in a few weeks at a remote anchorage like Eniwetok or Manus. The psychological impact of these dry docks on the enemy was profound, though delayed. Japanese pilots would report damaging a major American warship, confidently asserting that the vessel would be out of action for the rest of the year. Yet, a month later, that same ship would reappear in the battle line, fresh and fighting. To the Japanese, it seemed as if the American fleet possessed a supernatural ability to regenerate. They did not see the ABSDs hidden in the lagoons, the welding torches sparking through the night, the crews working around the clock to patch the steel. They only saw the result, a fleet that refused to die. The concrete barges and floating dry docks were staffed by a unique breed of sailor. These men lived on ships that never went anywhere under their own power. They endured the boredom of sitting at anchor in tropical heat, the constant drone of generators, and the lack of glory. They were the storekeepers, the crane operators, the refrigeration mechanics. They fought their war with clipboards and manifests, ensuring that every nut, bolt, and frozen pork chop was accounted for and delivered. Their motto might well have been, "We also serve who only stand and wait," but in their case, they stood and waited with the essential fuel of war in their hands. This floating industrial park was a triumph of American logistics. It turned the liability of a long supply chain into an asset. By bringing the infrastructure forward, the Navy compressed the time and space of the war. The concrete armada might have been slow, ugly, and mocked by the real sailors on the destroyers, but it was the bedrock upon which the relentless American offensive was built. It proved that in total war, innovation isn't always sleek or fast. Sometimes it's a big gray block of concrete floating in a lagoon, filled with enough ice cream to boost the morale of 10,000 men. If the floating dry docks and concrete barges were the bricks of this new logistical fortress, then Ulithi Atoll was its foundation. Located in the Caroline Islands, roughly 360 miles southwest of Guam, Ulithi was a geographical oddity that became the strategic fulcrum of the Pacific War. Before late 1944, it was a quiet, pristine ring of coral islets surrounding a massive lagoon, inhabited by a small population of indigenous people and ignored by the wider world. It appeared on charts merely as a navigational hazard or a curiosity. But to the logistical planners of the U.S. Navy, Ulithi was the Holy Grail, a natural harbor of immense proportions, capable of sheltering the entire Pacific Fleet. In September 1944, the quiet of the lagoon was shattered forever. The Americans arrived not with a trickle, but with a flood. Almost overnight, this remote atoll was transformed into the fourth largest port in the world. It had no piers, no cranes, and no buildings, yet at its peak, it harbored nearly 700 ships simultaneously. It became a secret city floating on the water, a bustling metropolis of steel and oil situated in the middle of nowhere. The transformation was orchestrated by Commodore Worrell Reed Carter and his Service Squadron 10. Carter was the architect of this mobile logistics miracle. He looked at the vast empty expanse of the lagoon, roughly 20 miles long and 10 miles wide, and saw a grid. He organized the anchorage into specific berths, a row for the carriers, a section for the battleships, an area for the ammunition ships, and a corner for the tankers. The chart of the lagoon became a chessboard of naval power. Life at Ulithi was a surreal juxtaposition of tropical idyll and industrial might. The water was a brilliant turquoise, clear and calm, while the horizon was cluttered with the gray silhouettes of the most destructive machines ever built. The Murderer's Row of fleet carriers, Enterprise, Essex, Yorktown, Hornet, sat at anchor, their flight decks baking in the equatorial sun. Surrounding them were the battleships, the cruisers, and the destroyers, all tethered to the bottom, resting like sleeping giants. But they were not idle. The lagoon was a hive of activity. Small boats, known as water taxis, buzzed incessantly between the behemoths. They carried mail, movies, spare parts, and officers transferring for conferences. The logistics of the mail alone were staggering. For the millions of men deployed in the Pacific, a letter from home was the most precious cargo of all. At Ulithi, the fleet post office operated out of converted barges, sorting tons of mail daily to ensure that a sailor on a destroyer received his packet of letters before his ship sortied for the next invasion. The supply chain here was fine-tuned to an art form. A destroyer low on torpedoes did not need to find a dock. A munitions lighter would come alongside, and crews would hoist the deadly fish aboard using davits and muscle. Fresh water distilled on specialized barges was pumped into the tanks of smaller ships that lacked large desalination plants. Every commodity needed for war, from 20mm cannon shells to toilet paper, was available within the lagoon. It was a supermarket for warships, open 24 hours a day. For the sailors, Ulithi offered a brief, strange respite from the terror of the kamikazes. The northernmost islet of the atoll, Mog Mog, was designated as the recreation center. It was a tiny patch of sand and palm trees that became the scene of one of the war's most chaotic social experiments. Thousands of sailors were ferried ashore daily for a few hours of liberty. The Navy organized a crude system. A baseball diamond was cleared in the sand, and massive quantities of warm beer were dispensed. It was hardly a resort. The heat was oppressive, the beer was often stale, and fights were common. Yet, for men who had spent weeks in the cramped steel confines of a warship, staring at nothing but the empty ocean and the enemy sky, Mog was paradise. It was a chance to feel sand under their boots and see a tree that hadn't been blasted by artillery. However, the war was never far away. The Japanese were aware of the massive gathering at Ulithi, though they were powerless to stop it with a conventional fleet. Instead, they resorted to desperation. In November 1944, they launched a Kaiten attack, manned suicide torpedoes launched from submarines. One of these human-guided weapons managed to penetrate the harbor defenses and struck the fleet oiler USS Mississauga. The explosion was massive, sending a pillar of fire and smoke into the sky that was visible across the entire lagoon. The ship capsized and sank, taking 63 men with her. The attack sent a shock wave through the anchorage. The illusion of safety was punctured. Destroyers raced through the lagoon, dropping depth charges, churning the turquoise water into a white froth as they hunted for the intruders. But the most telling aspect of the incident was what happened next. The fleet did not flee. The operations did not cease. The tankers continued to pump oil. The ammunition ships continued to load bombs. The American logistical machine was now so robust, so massive, that even a successful suicide attack was absorbed as a tragic but manageable operational cost. The Mississauga burned, but the fleet remained. Ulithi proved that the U.S. Navy had successfully broken the tether to the land. They had created a forward base that could move, expand, and function entirely at sea. This secret city allowed Admiral Halsey and Admiral Spruance to keep the pressure on the Japanese Empire relentlessly. The fleet could strike the Philippines, return to Ulithi for a week of rest and replenishment, and then sortie again for Iwo Jima or Okinawa. The Japanese High Command, waiting for the Americans to retreat to Pearl Harbor, waited in vain. The Americans were already at their doorstep, and they had brought their harbor with them. The tyranny of distance had been conquered not by shrinking the ocean, but by occupying it. While the concrete barges and secret lagoons provided the static infrastructure of the war, the true test of the Navy's new doctrine occurred in the open ocean, amidst the chaotic swells of the Pacific. Here, the engineers and seamen mastered an art that violated every instinct of a prudent mariner: the transfer of fuel and explosives between two massive vessels steaming side by side at high speed. This was underway replenishment, or UNREP, and it became the operational heartbeat of the U.S. Navy. Before the war, standard naval procedure dictated that a ship needing fuel must stop. It would drop anchor in a calm harbor, or at the very least, heave to in still waters to take a line from a tanker. To attempt such a maneuver while moving was considered reckless. To do it in rough seas was considered madness. But the exigencies of the Pacific theater had eroded the luxury of caution. A stationary ship was a target for submarines. A fleet that had to stop to eat and drink was a fleet that gave the enemy time to regroup. The Americans realized that to maintain the pressure, the gas station had to travel at 15 knots, right alongside the customer. The physics of this maneuver were terrifying. As a destroyer or battleship pulled alongside a fleet oiler, the water rushing between the two hulls accelerated. According to the Bernoulli principle, This increased speed created a drop in pressure, generating a powerful suction effect that tried to pull the two ships together. If the helmsmen were not perfect, if they lost focus for a second, the steel giants would collide, grinding hull against hull, crushing sailors and sparking fires that could detonate the fuel-laden tanker. Despite these dangers, American seamanship evolved rapidly to meet the challenge. The alongside method became the standard. A fleet oiler, a massive, deep-bellied vessel like the Cimarron class, would hold a steady course and speed, usually between 12 and 15 knots. The combatant ship, a carrier, battleship, or destroyer, would approach from astern, creeping up on the oiler's flank until they were separated by perhaps 50 to 80 feet of churning white water. Once in position, the dance began. A shot line was fired from a rifle across the gap, followed by a messenger line, and finally, the heavy hauling lines. Then came the hoses. These were heavy, unruly black pythons of rubber and canvas, suspended above the waves by a system of span wires and saddles. The tension on these wires had to be managed with surgical precision. If the wire was too loose, the hose would dip into the sea, where the drag could snap it instantly. If the wire was too tight, a sudden roll of the ships could part the cable, sending a steel whip slashing across the deck, capable of shearing off limbs or heads. The engineers developed specialized rigs to mitigate this risk. They introduced constant tension winches and the El Paso rig, which allowed the lines to pay out or retract automatically as the ships heaved and rolled independently. On the decks, the boatswain's mates and deck crews worked in a perilous rhythm. They wrestled the heavy hoses into the fueling trunks, hammered the couplings shut, and signaled for the pumping to begin. Millions of gallons of black fuel oil flowed across the gap, the lifeblood of the fleet pulsing through the arteries of the logistical train. But fuel was only half the equation. A carrier launching hundreds of sorties a day had an insatiable appetite for bombs, rockets, and machine gun ammunition. A battleship bombarding a shore installation could empty its magazines in hours. Thus, the Navy had to perfect the transfer of solid cargo at sea as well. This was an even more delicate operation. While oil could flow through a flexible hose, a 2,000-pound aerial bomb or a crate of 5-inch shells had to be physically swung across the gap. To achieve this, they utilized the Burton method, or yard and stay transfer. It involved a complex web of pulleys and lines connecting the masts of the two ships. Pallets of high explosives were hoisted into the air, suspended over the rushing water, and then winched across to the receiving ship. The crews watched nervously as tons of ordnance dangled precariously between the swaying hulls. One slip of a winchman's hand, one unexpected rogue wave, and the payload could smash into the side of the receiving ship or drop into the abyss. This capability transformed the tactical landscape. It allowed the fast carrier task forces to remain at sea indefinitely. In the past, a task force operated on a tether of time. The fuel gauge dictated the mission duration. Now, the mission dictated the fuel. Admiral Spruance and Admiral Halsey could keep their fleets on the enemy's doorstep for months. The Japanese commanders, tracking the American movements, would calculate that the U.S. fleet must be low on fuel and preparing to withdraw. They would prepare a counterattack, only to find the Americans still there the next morning, their tanks full and their magazines topped off. The mastery of replenishment at sea did not come without cost. The ocean remained an unpredictable adversary. In December 1944, the limits of this technique were brutally exposed during Halsey's Typhoon. The Third Fleet, low on fuel, attempted to refuel in worsening weather. The hunger for oil drove the destroyers to attempt the maneuver in high seas and gale-force winds. The hoses parted, the lines snapped, and eventually the operation had to be aborted. But the delay proved fatal for 3 destroyers, the Spence, Hull, and Monaghan, which, light on fuel and top-heavy, capsized in the monstrous waves, taking nearly 800 men to their deaths. The tragedy highlighted the razor's edge on which these logistics crews walked. Yet, even after the typhoon, the procedure did not stop. It was merely refined. The Navy learned, adapted, and continued to pump oil in the face of the elements. The Japanese Navy, by contrast, never mastered this art. Their fleet remained tethered to their bases. When they sortied, they were on a strict countdown. The Americans, however, had broken the clock. They had turned the Pacific Ocean into a continuous highway where the supplies never stopped moving, and the fleet never had to look back. The slow U.S. Navy had become a relentless, self-sustaining machine that simply refused to go home. In the calculus of naval warfare, a damaged ship was often considered as good as sunk, at least for the duration of a campaign. When a cruiser took a torpedo to the bow, or a destroyer had its engine room gutted by a shell, the strategic expectation was that the vessel would limp away, vanishing from the order of battle for 6 months to a year. It would have to slowly traverse the ocean, queue up at a shipyard in Bremerton or Brooklyn, and undergo a lengthy reconstruction. The Japanese high command relied on this attrition. They calculated that even if they did not sink American ships outright, damaging them heavily would strip the U.S. fleet of its strength just as effectively. They believed in the mission kill. But the U.S. Navy had brought the shipyard to the ship. In the anchorages of the Western Pacific, a different kind of miracle was taking place daily, one of fire, steel, and unyielding industrial will. The repair ships, the ARs and tenders, were the unsung heroes of this effort. These vessels were ugly, cluttered, and bristling with cranes, but inside, they were marvels of engineering. They contained fully functional foundries capable of melting down brass and iron to cast new parts from scratch. They housed optical shops to repair delicate rangefinders, electrical shops to rewind massive motors, and machine shops equipped with the finest lathes and drill presses American industry could provide. When a battered warship limped into a forward anchorage like Ulithi or Manus, it was immediately swarmed. The repair officer from the flagship of the service squadron would come aboard to assess the damage. Often, the damage was catastrophic. Gaping holes in the hull, twisted propeller shafts, flight decks curled up like sardine can lids by kamikaze impacts. In any other navy or in any previous war, the verdict would have been a trip home. Here, the verdict was often, "We can fix it in 10 days." The work was brutal and dangerous. The repair crews worked in 12-hour shifts, 24 hours a day, under floodlights that turned the tropical night into a harsh, artificial day. Welders hung suspended over the side of ships in boatswain's chairs, sparks cascading into the dark water as they cut away tons of mangled steel. Inside the sweltering hulls, where temperatures often exceeded 120 degrees Fahrenheit, fitters and shipwrights crawled through oil-slicked bilges to shore up bulkheads and patch steam lines. One of the most critical innovations was the use of underwater cutting and welding. Before the war, repairing a hole below the waterline meant dry docking the ship. But with the scarcity of dry docks, American divers mastered the art of working wet. Using specialized hydrogen torches, they descended into the murky waters of the lagoon to cut away jagged wreckage and weld watertight patches over shell holes. They worked by touch as much as by sight, fighting currents and the exhaustion of working under pressure. Their efforts allowed ships that should have sunk or been towed away to remain afloat, and crucially, to remain fighting. The speed of these repairs defied all established norms. There were instances where destroyers with their bows completely blown off were fitted with temporary stub bows made of timber and concrete, allowing them to steam under their own power to a floating dry dock for a steel replacement. The repair crews did not wait for parts to arrive from the United States. They fabricated them on the spot. If a pump casing was shattered, the pattern makers on the repair ship would carve a wooden replica. The foundry would cast it in metal, and the machinists would grind it to tolerance, all within 48 hours. This capability had a profound psychological effect on the enemy. Japanese pilots would return to base, claiming with certainty that they had crippled an American carrier or battleship. They had seen the smoke. They had seen the list. Intelligence officers in Tokyo would mark that ship off their charts. Yet 2 weeks later, that very same ship would be spotted off the coast of Japan, launching aircraft or bombarding shore positions. It led to a creeping sense of dread among the Japanese leadership, a feeling that they were fighting a hydra. For every head they cut off, 2 seemed to grow back. They began to doubt their own pilots' reports. They began to believe that the American fleet was infinite. The miracles were driven by a unique demographic within the Navy. The men of the repair ships were often older than the average sailor. Many were recruited directly from the shipyards and factories of the Depression-era Midwest and East Coast. These were men who had spent 20 years working with steel and steam. They were master craftsmen, boiler makers, pipe fitters, electricians who had joined the Navy not to see the world, but to fix it. They brought a civilian can-do attitude that bypassed bureaucratic red tape. If a battleship needed a part and the supply requisition would take too long, they simply walked over to the scrap pile, found a piece of metal, and made it work. A poignant example of this resilience occurred during the Okinawa campaign, where the fleet faced the full fury of the Kamikaze Corps. Destroyers on the radar picket lines were being hammered mercilessly. Ships like the USS Laffey and USS Aaron Ward survived damage that defied physics. Superstructures shredded, guns knocked out, hulls riddled with holes. Yet, they did not sink. They were kept afloat by the damage control parties trained in the harsh school of war, and then patched up by the repair crews at the forward base of Karama Reto. This small island group, captured specifically to serve as a repair depot, became a graveyard for Japanese hopes. It was here that the service squadron patched the wounded so they could limp home, or in many cases return to the line. The Japanese had gambled on a war of limited resources, where damage was permanent and accumulation of loss was inevitable. The Americans countered with a war of industrial renewal. The repair yards at sea meant that the U.S. Navy did not just consume resources, it recycled them. They turned the lagoons of the Pacific into industrial zones where the broken were made whole. The slow U.S. Navy was not only moving faster than the Japanese could track, but it was also healing itself at a speed that the samurai spirit could not comprehend. The attrition rate was high, but the persistence rate was absolute. By late 1944, the mood in the Imperial Japanese Naval General Staff Headquarters in Tokyo had shifted from cautious optimism to a cold, paralyzing dread. For years, their entire strategic worldview had been predicated on a rhythm of warfare that was as reliable as the tides. The enemy would attack, expend his energy, and then recede. This ebb and flow was the foundational assumption of the Kantai Kessen, the decisive battle doctrine. The Japanese expected to fight a pulse-like war, where the pauses between American offensives would provide the breathing room necessary to repair ships, train new air groups, and fortify the next line of defense. But the tide had stopped going out. The American fleet had arrived in the Philippine Sea, then the Leyte Gulf, and finally the waters off Iwo Jima and Okinawa, and it simply refused to leave. The pause never came. The slow U.S. Navy, which the Japanese had mocked for its heavy logistical tail, had transformed that tail into an anchor that held them fast in the combat zone. The shock of this permanent presence was more demoralizing to the Japanese admirals than the loss of any single battleship. It signaled that the fundamental laws of naval capability had been rewritten, and Japan had been left behind. Japanese observers on the occupied islands watched the horizon with growing disbelief. In previous years, an American task force would appear, launch airstrikes for 2 or 3 days, and then vanish to replenish. Now the horizon remained cluttered with gray silhouettes for weeks, then months. The bombardment was continuous. The airstrikes were relentless. There was no respite, no time to emerge from the bunkers to repair the airfields. The psychological pressure of this unceasing assault was shattering. It was as if a steel clamp had been tightened around the Empire's throat and was being ratcheted tighter with every passing day. Admiral Soemu Toyoda, commander-in-chief of the combined fleet, found his options narrowing to the point of non-existence. He had planned to catch the Americans off balance during their withdrawals. But how does one counterattack an enemy who never withdraws? The Japanese attempts to strike back were met not by a retreating force low on fuel and ammunition, but by a fleet that was fully topped off and waiting. The logistical machine operating just over the horizon, the oilers, the ammunition ships, the replacement aircraft carriers, meant that the U.S. Fifth Fleet and Third Fleet, which were essentially the same ships under rotating command, could maintain a level of combat readiness that defied Japanese comprehension. This strategic despair was compounded by the failure of Japanese intelligence to understand the mechanism behind this stamina. For a long time, Tokyo believed the Americans must have established a massive secret base on a nearby island to support such operations. They could not conceive that the base was the fleet itself. When reconnaissance planes spotted the vast assemblage of support ships at Ulithi or in the open ocean, they often misidentified them or underestimated their significance. They saw targets, not a revolution in warfare. By the time they realized that the humble oilers were the true center of gravity, it was too late. The air groups required to sink them had already been decimated by the American combat air patrols that never seemed to run out of fuel. The persistence of the American fleet forced the Japanese into the darkest corner of their strategic playbook. The shift to kamikaze tactics in late 1944 was not solely a product of spiritual fanaticism. It was a rational, albeit horrific, response to a logistical reality. Conventional attacks had failed. The Americans could absorb damage, repair it on the spot, and keep coming. Their supply of planes and pilots seemed infinite. The Japanese realized they could not win a battle of attrition against a force that replenished itself at sea. The only option left was to inflict such grievous psychological trauma that the American public would lose the will to fight. They had to turn themselves into the ultimate smart weapon, because they could not match the industrial tide washing over them. During the invasion of Okinawa, this dynamic reached its zenith. The U.S. fleet remained off the coast for nearly 3 months. It was the longest sustained naval campaign in history. The Japanese threw everything they had at the Steel Typhoon: thousands of suicide planes, rocket bombs, and the battleship Yamato itself. Under normal circumstances, a fleet subjected to such punishment would have been forced to withdraw to regroup. Ships were burning, sailors were exhausted, and ammunition magazines were running dry. But the logistics train held the line. Every morning, the oilers and ammunition ships braved the kamikaze threat to pull alongside the battered destroyers and carriers. They pumped millions of gallons of fuel and transferred tons of anti-aircraft shells while under threat of attack. This logistical heroism meant that the guns of the fleet never fell silent. The Japanese defenders in the caves of Okinawa waited for the naval gunfire to stop, assuming the ships would eventually run out of shells. The shells never stopped coming. The despair this induced in the Japanese command cannot be overstated. It was the realization that they were fighting a machine that had no off switch. Post-war interrogations of high-ranking Japanese officials revealed the depth of this shock. Officers admitted that while they feared the American industrial capacity to build ships, they had never imagined the Americans could operate them with such fluidity. They had mocked the luxury of the American sailor, believing the softness of the U.S. lifestyle would translate to weakness in war. Instead, they found that the American demand for comfort had driven the creation of a supply chain so robust it became a weapon in itself. The ice cream barges and the floating dry docks were not signs of weakness. They were the engines of endurance. By the summer of 1945, the Japanese Navy was effectively finished. Its ships were harbored in Kure and Yokosuka, lacking the fuel to train or sorties. They were tethered to the land, immobilized by the very logistical constraints they had expected to defeat the Americans. Meanwhile, the U.S. Navy roamed the coast of Japan at will, a self-contained empire of the sea. The mockery of the early war years had turned into a bitter silence. The slow U.S. Navy had not only outpaced them, it had outlasted them. The tyranny of distance had been completely reversed. The Americans were now at home in the Western Pacific, and the Japanese were strangers in their own waters. By the summer of 1945, the iron chain of American logistics had tightened into a strangling noose around the neck of the Japanese Empire. The war had moved from the periphery of island outposts to the very doorstep of the home islands. In July, Admiral Halsey's Third Fleet, A terrifying armada of aircraft carriers and battleships began a series of strikes that would have been logistically impossible just 3 years prior. They roamed the coast of Japan, launching thousands of sorties and bombarding industrial cities with impunity. This was the ultimate validation of the floating base concept. The fleet did not return to Ulithi or Pearl Harbor to rearm. The ammunition ships came to them, bobbing in the swells off the Japanese coast, feeding the guns that were dismantling a nation. The contrast between the two belligerents in these final days was stark and tragic. In the naval base at Kure, the remnants of the Imperial Japanese Navy lay impotent. The battleships Ise and Hyuga, once the pride of the fleet, sat rusting at their moorings, their anti-aircraft guns silent for lack of ammunition, their boilers cold for lack of fuel. They had become little more than steel islands, trapped by the total collapse of their own logistical network. Meanwhile, just a few miles offshore, American destroyers were purposefully burning fuel to distill fresh water for showers, a display of resource abundance that mocked the starvation gripping Japan. The logistical dominance allowed the U.S. Navy to undertake operations of unprecedented audacity. In mid-July, American battleships, including the Massachusetts and the Indiana, steamed within sight of the Japanese mainland to bombard the Kamaishi ironworks. This was not a hit-and-run raid. It was a deliberate, methodical dismantling of infrastructure. The ships fired over 1,000 tons of high explosives in a matter of hours. They could afford this expenditure because the supply chain was unbroken. As soon as the magazines were empty, the ammunition ships were there to refill them. The Americans were not just defeating the Japanese military. They were demonstrating that the Japanese could no longer protect their own soil from the industrial reach of the United States. This final phase of the war also saw the logistical train supporting the most effective blockade in history. While the carriers pounded the skies, U.S. submarines and B-29s dropping mines in Operation Starvation severed Japan's last lifelines to the continent. The irony was profound. Japan had started the war to secure resources, specifically oil, from the crumbling European empires in Asia. Now, they were drowning in a sea of American oil, unable to import a single drop for themselves. The American logistics system had not only sustained its own forces, it had effectively walled off the enemy from the rest of the world. The culmination of this effort was not a battle, but a gathering. When the surrender was finally announced in August 1945, the Allied fleet began to converge on Tokyo Bay. The sight that greeted the Japanese delegates and the citizens on the shore was incomprehensible. It was a forest of masts and superstructures that stretched to the horizon. There were hundreds of ships, combatants, transports, hospital ships, repair vessels, and the humble oilers that had made it all possible. It was a floating city of steel, populated by hundreds of thousands of men, anchored in the heart of the enemy's capital.
This gathering required a logistical effort that rivaled the combat operations. Even in peace, the fleet had to eat. The concrete armada and the refrigeration ships worked overtime to ensure that the occupying forces had fresh food. The water distilling ships pumped millions of gallons to support the sudden influx of humanity. The repair crews who had spent years patching holes made by kamikazes now turned their attention to maintaining the fleet for the occupation in the massive magic carpet operation that would bring the troops home. The surrender ceremony on the deck of the USS Missouri was the official end of the conflict, but the true victor was visible in the background of every photograph taken that day. It was the endless rows of cargo ships and tankers. The Japanese admirals who signed the instrument of surrender were not just bowing to superior tactics or fighting spirit. They were bowing to a superior system. They had gambled on a war of warrior spirit, where the brilliance of the sword would overcome the dull weight of the shield. They found themselves crushed by a relentless, mechanized juggernaut that replaced every broken shield with two new ones. The slow U.S. Navy had proven that speed in modern war was not about how fast a ship could move through the water, but how fast it could move supplies to the fight. The Japanese had mocked the American tail, believing it would anchor the fleet. Instead, the tail had become a whip. The engineers, the supply officers, and the merchant mariners had built a bridge across the Pacific, a bridge made of ships and sweat, over which the industrial might of America marched to victory. The empire was not defeated by a single decisive battle. It was buried under the weight of crates, barrels, and pallets, delivered on time, every time, by the silent fleet that refused to stop. The Grumman F-6F Hellcat and the Essex-class carrier are rightly remembered as the icons of victory in the Pacific. But the true architect of that victory was the grimy, unglamorous supply chain that kept them fighting. The Japanese defeat was a testament to a fundamental misunderstanding of modern war. They fought for glory, while the Americans fought for sustainability. The floating bases, the concrete barges, and the daring underway replenishments were not merely support operations. They were the offensive weapon that the samurai spirit could not parry. The legacy of this logistical revolution extends far beyond 1945. The U.S. Navy never returned to the static strategies of the past. The ability to project power anywhere in the world, sustained indefinitely by a fleet train, became the cornerstone of global superpower status. It proved that industrial might, when coupled with engineering audacity, could shrink the largest ocean on Earth into a neighborhood pond. And that is why these tales must be told, because the history of war is not just written in blood, but in oil, steel, and the triumph of the impossible made routine.